Welcome to Austin Community College's Physics 2 Equipotential and Electric Field Lines lab. Okay, well, in this lab, what we have here is we have a power supply. And on that power supply, we've got it cranked up to 1.5 volts DC. That's direct current. And then what we have here is a conductive piece of paper. It's a plate, we'll call it a plate of paper. And what we have here are silver electrodes that we've actually put on this paper. And we've connected to them. This is from the positive end of the power supply. This is from the negative end of the power supply. In the field, the potential difference between these parallel plate capacitor kind of setup here is 1.5 volts, 1.5 volts. And what we're going to do is find on this real paper, meaning that it's going to be imperfect because, you know, manufactured and so forth, but we want to record what we get. We're going to find voltages across this area, all the way across the area, and where their grid location is. Notice that we have a grid here. There's 8, 9, 10, 11, 12, 10, 11, 12, 13, 14. You can record these on your own lab handout. We're going to start out with finding a center of 0.3 volts, and we're going to go to 0.6 volts, 0.9 volts, 1.2. We're going to spread out 4 different same voltages on each side and get the coordinate of it. We're going to put dots there, and then that's what we're going to do. Okay, we're going to continue on with the ACC electric field mapping. What we did, you can see the voltage here is 0. This is where we've set our 0 potential on this electrode, moving across the paper all the way up to 1.5 volts. There we go, 1.5. So I'm going to start finding our equipotentials starting with 0.3 volts. So I'm going to come in here on this and hunt down 0.3. That looks like a spot right there. I'm going to do the first line. You're going to do it with me, and then we're going to give you the data for the other 3 equipotential lines. So for 0.3, we've got a 0 and an 18.3. I'm going to find one here. It looks like this would be a 2 and a 19. This looks to be 5 and 18.7. That was quick. 8 in the vertical and 18.5 horizontal. 10 and about 18.5 horizontal. 12, 18.6. Looks like 15 and 18.7. This looks to be 18 and 19. 20 and 19.5. Those are our points for the first line at 0.3 volts. All right, so this is our next plate. I'm going to do one line on this particular plate, and remember that this is our 0 potential as seen on the voltmeter. This is our 1.5 volts, and the difference is all the way across. I'm just randomly going to pick, I'm going to do your 0.6 line. So we're going to walk through. I've kind of already gone ahead and kind of narrowed it down. So this would be a point right here on the grid, which looks to me to be 20, or let's start 17 vertical and 25.5 horizontal. This would be another point. It's well, 16 and almost 24, just to the left of it, 23.9. This one looks to be about 15 vertical, 22 horizontal. That looks like 13 and 19.7, we'll call it. 10 and 18.5. 8 and 19.3, I would call it. That one happens to be 6 and 21. Again, 6.6 volts. Looks to be 4 and 24. Our final point on this would be, I'm going to go really 2.5 vertical and 28 horizontal. And we're going to provide the grid points for the other 3 equipotential lines. Okay, continuing, this is our third plate. We've got 2 points. Again, this is 0 potential and moves all the way up here on the voltmeter to 1.5. I just randomly, I'm going to hunt down and show you, you have to take off the video, the points, equipotentials for 0.6 volts. And after that, we're going to give you the others, because the real work is going to be finding the electric field lines. So beginning here, I've got one point here, looks to be 0.6 volts, 19 vertical, 17 and 0.6 horizontal. I've got a 17 vertical and a 17.3 horizontal. I've got actually a 15 and a 17. Another point right there, 0.6 volts. Here, this one pretty close is 13 and 16.5. Dead center looks like we have 10 and 16 point, I'm gonna call it 2. We have in the vertical, we've got 7 and 16.8. Here we have 5 and 17.3. Here we have vertical is 3 and 18 horizontal. Our last one for this 0.6 is going to be, looks to be 1 and 18.3. And that's our 0.6 line, and we're going to give you data for the rest. All right, I just wanted to briefly explain part 3 in the electric field mapping lab, just so you're oriented. And the whole idea is this: if you have the lab in front of you, it's E equals delta V over delta S. So what we want to do for the parallel plate capacitor is to estimate the strength or the magnitude of the electric field and see if it's uniform. If you follow the lab and what I'm going to point out here, I think you won't have any problem. So what we want to do is we want to take, you've drawn in these equipotential lines, the best fit line, you don't have to connect the dots in the idea. And you're missing the 0.3 volt, that's the one that I gave you in the video that you've already included. But we're going to measure accurately the distance in meters. I'm using millimeters here, but we're going to convert to meters. The distance S across here. You know that the difference is going to be between 0.6 and 0.9. In fact, it's given as 0.3 volts. And you're simply going to find the strength of that across there, delta V over delta S in meters. And then you can do the same thing on this side with the 0.3 line that you had, wherever that is. It should maybe be a slightly different distance. Get E. You're going to go over on this side, find E, delta V over delta S, spot below it, or above it, and a spot below it, and then answer the questions on part 4.